So we're going to continue on the previous session on t-test. Now here the point is to look at the importance of central tendency and dispersion. And we need to examine central tendency and standard deviation as a measure of dispersion simultaneously when we are doing t-test for the relationship between a dichotomous fieldable and continuous fieldable. And here's why. I'm going to come up with completely different scenarios here. And we're using the same variables we discussed before. We're using gender and traffic tickets. So that's why you have two subsamples here. And we're going to look at the frequency distribution of traffic tickets across these scenarios. And I'm going to actually designate same central tendency for same gender group across these scenarios. Now, the first scenario has a frequency distribution of number of traffic tickets for female subsample like this. And the distribution for male subsample is like this. In this particular scenario, you don't even have to run t-test. It is plain to see that there is a distinctive difference between male and female subsample in terms of number of traffic tickets. So you can confidently reject the null hypothesis stating that there is no difference between male and female subsample. And you can go on to say that the mean number of traffic tickets for male subsample is higher than mean number of traffic tickets for female subsample, and you can conclude that males are more likely than females to receive traffic tickets for whatever reason. Now, look at this next scenario. This is the frequency distribution of number of tickets for female subsample, and this is for male subsample. Now, notice this overlap. Where does this come from? It comes from this wider dispersion when compared to the same location here. This wider dispersion compared to this first scenario. And this substantial overlap now jeopardizes your decision making on null hypothesis. Now, one might say that now I see so much of an overlap, so I think it's tough for us to reject the null hypothesis. While another might say we still see this much of a unique differences pertaining to each subsample, so probably we can reject the null hypothesis and say that the two are quite different from each other. Now, this is why this overlap and the problem with the visual confirmation of this overlap, that's why we need to run t-test and obtain t-value and then compare that with critical value that can be obtained from the t-value table with degree of freedom and certain level of confidence. Now, let me show you another scenario where there is a dramatic overlap like this. If you look at the overlap here, again, it comes from this a lot wider dispersion compared to the same location in the first scenario. This wider dispersion, as a matter of fact, this is not the dispersion. This dispersion is from here to here. The dispersion of number of traffic tickets for male subpopulation is this much. Compare this to this. This is where the overlap lies. And this overlap is obviously larger than the unique difference pertaining to each subsample. Now I think it's safe for us to say that there is no difference between male and female subsamples in light of number of traffic tickets. So in this case, you might not want to reject the null hypothesis, and you probably accept the null hypothesis and say that there's no difference. So, but again, there's still a possibility that another person might look at it differently and say that you cannot ignore these differences. And that's why you need to run t-test.